Okay, first I would like to thank Mr. Benoît de Magny, the Industrial Director of INGREDIA, who accepted to sponsor this presentation today and to share the information with you. He was not able to be here due to traveling, but he shared the information with me too. And I am part of the project we will share with you today as the project leader who implement the solution with them and working as a consultant as well with INGREDIA. About myself, I am an independent consultant working in the, let's say, MES space and MOM space, and I am also a board member of the MESA Europe and the similar organization in France called Club MES, who both organizations trying to announce the good things about MES in the industries. Okay. As we said, energy is something, energy costs are increasing day after day and years after years. You have in the graphic here the energy cost evolution. It's in relation with index 100 in 2000, and you see that the energy, and you have here energy, electricity and gas. You have gas in green and electricity in orange, compared to the evolution of the price of life, the cost of life. Those information are coming from Eurostat. And you see that energy is increasing quicker than the normal cost of the life. In the next, the next part of the presentation, I will call energy with the energy term for gas, oil, fuel, but also water, hot water, steam, and all of kind of energy resource you could use in production plant. Today, we could say that in almost all the industries of the plant, people and management knows who are the big consumer in their plant. But you see here in a survey done in France last year that more than 10% of people doesn't know who are the big consumer in the industry. And it means there is place to improvement there. But if we go deeper in the survey and to the question, are you able to create internal bill for energy cost per department per usage? Only 36% of the people are able to do so. And I would like to make the survey here. How many people here are able to manage internal bills related to energy? Oh, it's not a lot. It's confirming this. And for me, it's not enough. It's good to know and to send an energy bill per department and to know what is the part of the production in the energy bill. But it's maybe not enough. And I will explain you here some of the best practice I would recommend in energy management. First is to know what are standard values for energy. It means what is the cost in euro of energy in 1 unit of product, in 1 unit of gas oil, 1 piece of 1 chair, 1 table, 1 liter of milk. What is the cost of electricity, steam, fuel for each unit of product? You know on your plan how many times it takes of the machine to produce this unit of product. You know how many hours or minutes of people are required to produce this. But you don't know what is the cost of energy. And in some processes it's very important because energy is increasing. And the weight of the energy in the production cost is higher and higher every day. One also thing is to give you the capability to be flexible in terms of selection of the energy you will use next day. If we take the example of the steam, you could produce steam from gas, from fuel, from biomass, from some different source. Knowing what will be the production tomorrow, and according to the economic situation of and the price of each different source, primary energy source, you could decide that tomorrow you will produce more with gas and less with fuel, and maybe starting a biomass boiler. But to do so, you have to make the link with the real-time activities of your plant. And when I say real-time activities or production line activities, it's not only production orders. It's also stoppage. It's also meetings. It's also a maintenance period of time. It's also changeovers. And if we take only changeovers in food industries, many times the changeover itself is more consuming energy in terms of energy than the production itself. You have to clean, it means consumer of water, or you have to sterilize or things like this. And this non-production activity is a highly consumer of energy. Knowing what we said, the standard values and the actual values, because you are taking measurements in your system, you can take the opportunity to make alerts on deviations. Why not doing SPC on energy parameters, like you do on quality or different things? And I make a calculation there. If you have a motor, a 4 megawatt motor, if you have a 10% deviation in consumption due to dust or external situation, it will cost you more than 30,000 euros per month of electricity. In addition, it's something you can detect by inserting in your normal MES stuff an alert on a deviation for energy consumption. And also you have today many application making reports, operational reports, or production orders reports, and you have the quantity of raw material, you have the time consuming to do this production order, maybe the comparison with the standards for those. You don't have the energy consumed, with the difference between the standard and the actual values. And this allows you on a yearly basis to review your standards according to what was done on the past year. But maybe you say, he's dreaming. No, I am not dreaming. What I explained there is what INGREDIA was implementing and is using today. And INGREDIA is a food industry preparing and delivering some ingredient from milk. They are receiving 1.3 million liters of milk every day, something like 100 trucks, collected in the area of Saint-Paul-sur-Ternoise in north of France. And with this milk, they are producing 200 tons of dry product per day. I prefer saying per day number because it shows you a better idea. And they are producing these dry products using 4 evaporation lines and 3 drying towers. And those equipments are highly consuming steam. They are producing 30 tons per hour of steam at both 15 and 30 bar networks. And you have some samples of the product where the ingredients are used. In 2008, making the conclusion that energy is something very costly and more costly, they decided to invest in the following years and starting in 2009 in two projects. One was to install a new boiler to produce steam, and they make the choice of a biomass boiler to substitute the two gas boilers they have. And the second project was the automation of energy cost calculation. It means replacing manual things in Excel sheet by automatic collection and process to have the standard values and the actual values of energy consumption. The biomass steam boiler they install is the largest biomass steam boiler in Europe for food industry. It is producing 25 tons per hour of steam, burning 5 tons, a little bit more than 5 tons of thread of wood per day, per hour, sorry. And you have the dimension of the building which is covering both the boiler and the warehouse for the wood, because with 5 tons per hour, it means you need space to store the wood before it's burning. And here is a quick description of the repartition of the network of the steam network. In addition to the installation of the new boiler, they take the opportunity to install also two heat exchanger, where it is a steam air exchanger at T and R equipments, in place of burning directly gas into air to heat the air. One thing about this is the fact that in reality the wood steam boiler is dimensioned to support normal operations, but it is not dimensioned to support extra or overloaded, because maybe you know or not, cows are not producing the same quantity of milk every day. An industrial cannot manage the way the cows are producing milk. But they have to consume and to treat all the milk produced every day. Then they have various quantities to treat. And some days they have to manage more than normal activities. It means in this way that they are continuing to use the one of the gas boiler they had before as the emergency input for steam. And also they are using economical information with the price of the wood, price of the gas, to select the ratio of gas boiler and wood boiler they will use to produce the steam. For example, if the price of the wood is increasing for local reason for 1 or 2 days, they will use gas boiler. And they make the decision, after making an analysis, they make the decision to put the gas boiler in a ready state status. It means the gas boiler is running, is ready to produce steam, and they make the exercise that it is costly only 30 euro per day. it's better than waiting 1 or 2 hours that the boiler is ready to produce. Then in this network, you have normal operation with the wood boiler, but with one gas boiler ready to inject steam to supply the extra load. Some benefits of the biomass. Why did they invest in this? Because it's not a small investment. In fact, the major benefit is the gas substituted by wood in terms of cost. They substitute more than 100,000 megawatt hour of gas. Knowing there is a difference between the price of 1 megawatt hour coming from gas or from wood, they make the benefits there. We talk about something like 10 euro per megawatt as a difference. And the difference is remaining stable along the years. The wood is increasing in the same way gas is increasing. And they have also some benefits from the environment. They save more than 22,000 of tons of carbon dioxide per year. Now there is some risk and issue related to working with such a boiler. The management of the boiler is an important point, because a wood boiler has a response time lower than a gas boiler. When you talk about second as a response time for a gas boiler, you have to talk about in minutes. With some equipment such as evaporator, where you have, when you start an evaporator, you have an increase, a quick increase of consumption in steam. You have to work with synchronization between production plan, production activities, and the management of the boiler. In this case, they are not allowed to start the 4 lines at the same time. They have to start the first, wait 15, 20 minutes, start the second one, and so on. And you have a synchronization between the wood boiler and the production. One issue they have, and they had at the beginning, is the quality of the wood delivered or supplied by the regional suppliers. Especially talking about humidity. If you take 1 kilo of wood, dry wood, 100% dry wood, you can expect 4 kilowatt hour per kilo. If you have just cut wood or 50% dry wood, you have only 2 kilowatt hour per kilo. It means on the yield is very important. This kind of things, the quality of the wood could be the source of a decision. I don't have the right quality now. I will prefer to work with gas for 1 or 2 days in order to solve the problem, and I will come back to the wood later. And one point I didn't mention is also that this wood boiler has to be stopped at least 4 weeks a year for big maintenance work. It's also the reason why they keep the gas boiler ready to run. And another point, not the least one, but and not directly for INGREDIA, but for other industrial in the area. Such a boiler is using all thread of wood produced in 100 kilometer area around INGREDIA. If industrial are not working on a wood industry, local wood industry, we are not talking on keeping the wood from Canada or Brazil or something else, it is not possible to install a second biomass boiler in the 100 kilometer area. Now, let's move to the second project. and talking about this standard cost. When you are preparing your budget, everybody is talking about raw material cost, resource cost, but a few are working on energy. INGREDIA is working with energy cost when they are creating the budget and when they are creating the selling price of the product. They know exactly how many euros are due to energy in a selling price. And they create an Excel spreadsheet where they have here the different products and the cost of producing this product in electricity, in steam, cooling, water, compressed air, gas, and wastewater. And for some generic operation, they have the same kind of calculation. Packaging, for example, is the same price for any product. They know that for packaging, they have a cost, a quantity of electricity, a quantity of cooling, and so and so. And they have also the cost of producing secondary energy. What is the cost of producing steam? And in this case, the graphic is not correct because they have two lines for steam. Steam produced per gas and steam produced per biomass. Compressed air, water, and cooling, and so. And after this, the management, the finance department can translate this in euros according to the contract they have with electricity producer or so on. It was let's say, administrative work to prepare the standard price. Now they have to go in a further step to collect information to verify that the numbers are correct. And to do so, they install some energy meters when required. In this case, and to store these values in a database. In this case, they make the choice of low price meter systems because the goal was not to make invoices, it was just to have a good value and to see the evolution and to see if it is correct. I have one personal tip here, and the personal tip is that you have in your process, you could use in your process virtual meters. You have in your PLC a big amount of data. We were talking about big amount of data earlier with Microsoft. You have big amount of data. You could transform this data into energy information. You could, let's take the example of a motor. Again, a motor. You have the power of the motor. You know in your process how long the motor is running. And you have immediately the energy consumed for this motor. We're talking about the constant speed motor, things like this. But you have a lot of examples where you can, from a process parameter, convert it into energy consumed. And this reduces the cost of implementing energy meters. Oh yes, this is just to explain and to show a trend, but it is a standard trend you can have from any product showing the evolution of your flow of energy. Now, you have the numbers, you have the system to collect information. You could go into activity-based costing. You could define, and what they did is to look to what they are doing in the production facilities and define every type of activity. What is a production order? It's a changeover, a cleaning, a close period, a meeting, a maintenance, with particularity to meetings and maintenance that are activities that suspend a production order. And you make the link between those activities and the energy consumed. and you create a report or a part of a new section in your production report where you select the type of activity. Yeah, what is new, it is not only production order. Then you need to make reports on other activities as well. You have to store the quantity of energy, the quantity of unit of product for this last activity, and the family of the product. With this, you prepare your analysis to make better in the future. You have this as a basis to create the, SPC or things like this to detect quickly deviation on your production consumption. And for sure, the best way to couple with the MES initiative is and it's also a good way to introduce energy as a benefit of your MES initiative. Nobody is doing this. But if you think about reducing the quality increasing the quality of your product for 1 or 2%, it means that you decrease the quantity of energy consumed to produce in the same way. And it's not a small amount, depending on your processes, of course. Okay, then they implement those deviation alerts. And this also makes the production people aware of energy issues. Because they have in every report, oh, you're not good in this last production order, you were not good, or you are better, why? Because I stopped earlier the evaporation line. But it's also a good way for finance people to understand what's happened. Because let me talk the story where you have the finance director saying to the production one, oh, last month you were good in energy consumption. The invoices are 20% lower. And the production said, yeah, but we had 2 lines stopped for 1 week. In fact, in this case, the energy cost per unit of product remains exactly the same. Maybe higher. Then it's an opportunity to make a monthly review of your energy cost according to the production. And because it is in the production report, you know exactly what's happened 3 weeks ago. You can put in place a strategy to select the right energy to produce a secondary energy. And you could measure exactly what is the impact on the selling price of the modification in the price of the energy. And maybe this will introduce a need to invest in reviewing the process engineering. You have something that you produce with the same way since 10 or 15 years. It may be the good time now to review if there is nothing else that produces the same result but using less energy. The point, risk and issue, is the fact that you need to be aware, but as in any MES project, on change management to inform people why are we doing this. Everybody must be concerned on this. And one important point is, as the metering system is not required to run the process, it's maybe more difficult to make it reliable. There is no reason for maintenance guys to go there, replace a metering unit, because the line is not stopped. But it is important in terms of management. My conclusion, but I think it is the conclusion, that INGREDIA could say, because they decided to do in this project, is knowing in real time the cost of energy per unit of product, and it is important, is per unit of product, is mandatory to improve continuously the performances of the production facilities. It's the only way to continue day after day, months after months, years after months, to know and improve the energy consumption, and not doing one spot. Thank you for your attention.
Thank you very much for this interesting presentation. Are there any questions from the audience or from the internet?
If there is no question from the audience, I'd like to bring up the issue that was mentioned here. INGREDIA, did you develop this energy management system together with partners, and which products were used?
Mainly they are working themselves on creating all the strategy, and the standard cost was done with a famous project, the Excel sheet. Microsoft is not there anymore. The biggest MES product on the world. But for the collection, they use a product coming from Synthetis, a Belgian company providing MES solution.
Take also into account the costs and efforts related to the increased plant and process complexity?
Excuse me?
Do you also take into account the costs that come with the increased complexity of your plant and of your process?
It was something we had in mind developing the solution. It means reducing what people has to do to manage. In fact, now they make the connection with the Foxborough DCS, where we take the information, start production order, stop production order, we take the quality, the product definition that they are producing, we take the quantity. That it means the energy management is somewhere for operational people completely transparent.
Well, thank you very much.
Okay, we have one more question here.
You talked about using energy as an ROI measure for MES projects.
Yeah.
Now, I'm interested in the following. Do you estimate that gain up front? And if so, how do you do that without having the context of, say, your activity follow-up and all that in place? In other words, the energy ROI that you talk about, is that something you can only measure after you've done the whole project? Or is it something you can really estimate properly up front?
In many cases, you have the opportunity to do upfront. Because, for example, you could take the thermodynamic formulas to know the minimum quantity of energy required to dry product in a drying tower. Right. It means if you are not...
Just for clarity, I'm not talking about the ROI associated with putting in place a different type of energy source. Yeah. I'm talking about the ROI you contribute to the MES project as such. In other words, okay, the ROI associated with having the contextualization of the data or the real-time follow-up.
But let's take the example of quality. You know that you would like to increase the quality of product by 2-3%. If you know the quantity of energy required to produce this, as you know today the quantity of minutes required by human to produce the quantity, you have the return on invest. You make the exercise today with, I am using, by increasing the quality of 2%, I reduce the time of usage of the production line by 10 minutes a day. Why not saying 10 kilowatt hour? It's similar. But you need to first know what is the quantity of energy used to produce such a product. It's the first step. Yeah.
I think Michel is saying that it is difficult to distinguish the process benefits from the MES benefits.
Yeah.
But that you can calculate the total benefits.
Yeah. Yeah, it is not alone. It's a combination of many things. But when you calculate the ROI, and I talk with many people, and I'm working with the MESA in the ROI guidebook they are preparing, energy is only one factor. But in some processes, it could be an important one.
Okay. Any other comment? No, then thank you again for this presentation.
You're welcome.
And we'll hand the microphone over.
Thank you.